Okay, I believe we're now recording. So it actually took me a while to go back in my mind and recall a good way to show you why the distribution of sample means will, approximate the expected mean outcome. And this is particularly true in sort of survey research. Is to use coin flips, and in coin flips, we know that people out there can be flipping coins all day. There's a population of coin flips, but you really only have two outcomes. You either get a heads or a tails. Every time you flip a coin, you're either going to get heads or tails. Just like when you have a baby, you will have a boy or a girl. And so when you only flip one, we know that we expect to get in a fair coin, we would expect to get half heads and half tails. It's a 50-50 proposition, and that's what this is demonstrating right here. This very nice 50-50 proposition. But then let's say we go to two coin flips, and now we have samples of two coin flips. Now what we have is, if we want to look at outcomes, we have, instead of one outcome, heads, or or tails, we now have four possible outcomes. We have outcome one, which is heads, heads, and 0% tails. We then have outcomes 2 and 3, which are heads, tails, and tails, heads. This is, nicely, 50% of our outcomes are tails, exactly what we expect it to be. Half of the time we get tails, half of the time we get heads. And then we have the tails, which is all tails. So you have four possible outcomes that I've graphed here, which are made of a histogram for here, which are 0% tails, 50% tails, and 100% tails. Notice that it's centered on the 50% tails. And so that you might see this as the very beginning of a rough normal distribution. Now, if we go to four flips, we go from four possible outcomes to 16 possible outcomes. And if you'll walk through these a bit, there are two extreme outcomes, which are all heads, which would be 0% tails, or all tails, which is 100% tails. So out of 16 outcomes, 1 out of 16, or 6.25% of the samples, should produce an all heads outcome, and 6.25% of the samples should produce an all tails outcome. If you think of the normal distribution, we talk about what percentage of the distribution lies beyond a certain point. Well, you have 14 intermediate outcomes, outcomes 2 through 15, which are anywhere from 3 heads and 1 tail to 3 tails and 1 head. And so those outcomes will be more the center of the distribution. And then, so we have then our 4 outcomes that are at 25% tails. And we similarly have 4 outcomes that are at 75% tails. Notice that in the center, we now have, instead of two, when we flipped the coin twice, we had 2 outcomes that were at 50% tails. We now have 6 outcomes that are at 50% tails. And I want to make a point here, which is, if you think about it, when we had just 2 flips, we had 2 possible outcomes that gave us our expected frequency of 50% heads and 50% tails. When we moved to 4 flips, we've doubled the sample size, but we've tripled the number of outcomes that give us the expected outcome of 50% heads and 50% tails. And so this is what the frequency distribution of sample means for sample size 4 is, which is that we now have these 6 outcomes, and this indeed is beginning to look, whoops, lovely curve on my part, more and more like a normal distribution. Mathematically, what's happening is that when you have 2 outcomes, when you have 2 basic sampling outcomes, like heads or tails, Clinton, Trump, HIV positive, HIV negative, the number of possible outcomes you have on sample size is given by 2 to the x, where x is, in this case, the number of flips or the sample size. And so when you have 2 flips, you have 4 possible outcomes. What we saw then too was when you have 4 flips, we had this that we graphed at 16 outcomes. If we go to 2 to the 6, you would have 64 out, and this is the key difference. When you go from 2 to the 6 to 2 to the 10th, you're increasing the number of flips by 4, but you're increasing the number of outcomes by 960. The number of possible outcomes when you flip a coin 10 times, so if we take samples of size 10, you would go and you would have 1,024 possible outcomes. Now, that obviously I don't have enough tablet paper to walk through each of those, but they are increasingly going to be centered on the idea that you would have about 512 heads. Think of all the combinations you could get for 512 heads and 512 tails. One way to think about that is think about if you somehow flipped 512 heads in a row and then 512 tails in a row, and then you move one tail over 512 times, each for each of the heads, so that you would then have all of those outcomes. I'm sorry, I said that wrong. So think about having 10, you only have, if you had 10 tails in a row or 10 heads in a row, those are singular outcomes. You have a 1 in 1,024 likelihood of getting 10 heads or 10 tails. Think about getting 5 heads in a row followed by 5 tails. Now that's a singular outcome, but then you have, if you just move over 1 at a time, you have 5 more where if you move tails to the 5th position and heads to the 6th position, tails to the 4th position, and heads to the 5th and 6th positions, you then have 5 more opportunities to get 5 heads and 5 tails, and that happens for each of them. I can walk through that a little bit more in class, or I can provide I'll provide a couple of samples of 10 or something to give you an idea. But what I wanted to I don't want to get ahead of myself, but basically you can see that the number of outcomes is going to increasingly center on something like that. And so that's why we just continue to get a steeper and tighter normal curve. As I just mentioned, another way of looking at this is to go in reverse and look at the outliers. There will always be in a coin flip or in a presidential poll with 2 parties, 2 unique. You could poll that everybody supported Hillary Clinton or everybody supported Donald Trump, but there's only one combination of samples that will give you that. And then there are thousands of combinations of samples that would give you 43-46 or 50-50 or 48-52. And so the larger the sample is, the less likely you are to hit the extremes. When we only had 2 flips, we know that we're going to hit the extremes half of the time. We either get 0% tails or 100% tails. With 4 flips, we've already decreased that from from 50% likely to, or that was with 1 flip, from 50% likely to 6.25% likely. Once we go to 10 flips, we're about we're about 0.1% likely to get an extreme outcome. So that concludes this handout, and I hope it's been helpful for explaining sampling. And let's just sort of see where we